So, this is our second last official classes, right? Next week we will be doing a review section and Q&A, and the very last first day. So this is uh, our first teaching class in this room. And next week we will be doing a review. Okay. So we will be finishing the regression. If not today, will be first day. So shouldn't be something that too much worry about, but because the regression you will be, if you ever use it, you will learn more from the second class, but our class will be surface introduction and what might you be see for the upcoming classes. So to remind you what we are doing for regression is trying to say there are two variables, right? Numeric variables by numbers, not category, right? ANOVA is numeric versus category, right? Where the groups are different, okay? But now we have the grouping is by numeric, so which means that it's meaningful, right? Say, for example, when study how much time you spend in school and versus earning, that's, I guess, is the most important thing in, I think, your life, right? I mean, probably you would decide whether to continue 1 or 2 more years in the school before you go to the job market, right? Or after you get to the job market, whether you want to stay there, right? So that is a very important question you want to know, right? And also a lot of time, right, is you want to see how many advertisement expense would increase your sales, and that's a basic question that we understand. And a lot of time we do a lot of stuff, and that is regression tells you so many stuff. So basically, you can imagine when you have data and you want to discover how things lead one lead to the other, then regression is the only goal you can use, right? And that is, if you know, understand the developments of the say AI, LLM, right? Basically, they are a special type of regression, but so basically, regression is underlying the data, right? And data has come from real world, so that is the main thing, right? And just to remind you that the data we have can be characterized by pairs, right? X1, Y1, right? Individual one's observation on X and Y, and the goal is to use X to explain Y. So Y, the main thing is when you want to predict Y or explain Y, okay, and you would do is Y bar, right? What suppose I want to explain education and income, but if I don't know education, the income you would say is average income in society. It's good to predict. And you will try to explain why a particular individual has higher income than others. And if by education will be just X, right? So basically using the X to give you a better explain or better predict Y. Okay. So that is the main idea. Okay. So that's why you would build for regression has two important meaning. First is you have a complex data points. It can be many, depends on how many samples you have, but you collapse it into two numbers, which is a slope and intercept, right? So you simplify a complex data into one or two numbers in this case, right? Is A and B. And second would be you are extending not just the number of the data to all the X and Y that you don't have value for, right? This is a final number of the number, but there are many X that you don't have data on, and then but you postulate or you assume that is a line would fit this. So that's why you generalize the knowledge. Okay? You simplify the data with the first row. The second one is generalize the knowledge. So there's two important tools that learn from that. Okay? And we know how to redraw the best line is to minimize the sum of the vertical square distance. Okay? And we explain why we look at vertical distance or horizontal or perpendicular, because we want to use X to explain Y. The vertical distance represents how good our guess is, so we want to minimize this problem. Okay? And that is what we call the least square method. Okay? And this method, as you can see, there's nothing statistics, right? There's data on the fine line. So we actually, that's why when you learn, if you ever learn linear algebra or learn anything without statistics, actually you also introduce the least square method. So it doesn't have to be anything statistics, okay, so far up until at this point, right? And the only thing you learn, if the least square, the best coefficient like this, right, it still has no statistic, right? Although the B can be written as covariance over variance, right? But you do remember that variance covariance need not be probability, right? You learn topic 1 is summaries, talk about descriptive statistics, need not be probability, right? Need not be random variable. And so over here, there's no random variable, right? And we all know that in particular, this line will tell you, this line will pass through the center of data, X bar, Y bar. The main reason is, as we said, if you give me the average education, then what is the best guess is the average income, right? And you try to say when the education is below the average level, then you expect the income will be below the average level. If your education is above this average level, then your income is above the average level. That is true when the slope is positive, right? If slope is negative, you other way around. But the main idea is your guess is based on whether the education is above or below the average, right? And you adjust according to the B's and plus A, right? So that is the idea behind this regression line. And we know there are some, I mean, this very trivial thing is like if you have the covariance is positive, of course the slope is positive, the covariance is negative, and slope is negative, right? There's nothing is zero, there's zero, there's nothing surprising. But this particular point out that if they are unrelated, right? So the Y will be just Y bar, right? Just simply that if X is no use, then you predict what is the Y, just simply Y bar. Okay? So that is the idea, right? So that's why we're explaining the deviation from Y bar by deviation from X bar. Okay. So that's negative, negative, as we said. And you look at the formula, if your variance X increased, the graph shows you that something like this would occur. And similarly, if you double your X and then your Y B will be half, right? And if every Y increase by 1, and then the A will increase by 1 as well. So these are things that you can check pretty easily from the solution. And we saw that from this regression, we also know how to calculate them, and we show you how to do it in Excel. It's called intercept and the slope, right? So that is something you can take a look. But I think I asked you to do this in the optional assignment, but I guess you don't need to submit the assignment, so you don't have to worry too much about this part. Right, as I said, I'm not super interested in computation in your exam, so you should not be too much worried about actual working on the stuff rather than understanding how they operate. Okay. So the next would be, actually now we're talking about probability, right? We need to consider the sampling error, right? So that is actually the epsilon. The epsilon I actually representing this model, right? And we assume that the underlying Y is actually given by alpha plus beta X, but there's something is not captured in your model, maybe some sampling error, maybe something is not X, it's called epsilon I, is something you didn't capture from the data. And of course, this thing have mean 0 and constant variance sigma square, and each error is unrelated. Okay, so the simplest case, and also X is a constant. So the only thing in this model that is a random variable only is epsilon I and also the yi, right? Because xi and is a constant by the second assumption, and alpha and beta are some number that you don't know. It's a problem. There's some number you don't know. Maybe 2, maybe 3, maybe 4, but it's not random. Okay. The only random is epsilon. The epsilon is a random because something is not captured in model. Okay. And that is the general thing we say, right? And this error is small, so this mean is 0. Okay. Have same variance. Okay. And what does this assumption buy us? Okay. And why do we need to make this assumption? It's because we want to say, okay, we do the estimated A and B, right, which we do it the least square method, minimize the vertical distance. What does that gain us? Okay, is anything? And turn out to be, if you believe the 4 assumption there, the calculation we do has a nice property to estimate alpha and beta, right? The alpha and beta underlying what is actually how x and y are related. Okay, of course, they are polluted by epsilon I, but we know that if you do it in this way, we can get alpha and beta on expectation that's got unbiased, right? It means that if you run regression from one data, you collect another data, you run another regression, you many regression, you have many A's and many B's. Average of those A's will get alpha, average of those B will get you beta. And also the way it's efficient means that if you want to guess, this is also the best among the class of linear predictor. Okay, I mean, I guess it's very difficult to see why linear thing is important, but you will learn this if you want to do it. But at least you can say this is a good thing. Okay, this is a good thing to do estimation. Okay, and technically there's scope to do, but I guess it's very classical. Okay, but anyway, there's a modern version of this Gauss-Markov theorem, but more or less the same. So basically what he said is very good. Okay, least square has no problem. And that's justify why we want to do vertical distance. We don't do horizontal, we don't do diagonal, okay? Because this has a very nice property there. So I hope I explain somehow why this is true. But of course, you may not be super happy because we put a lot of things under the rug, but I mean, we only have 1 week or 2 weeks to cover this, so we can't give you great detail. But if you really want more, you should do 2021, and this gives you whole semester looking about regression. Okay, so this is, I think, just we're trying to give you some idea what's going on there. Okay. And as expect now, what is the interpretation of A and B now, right? What do you find, right? And B will be, now the idea would be on average, right? Because the model is not a linear one, but a model with a error term. So that means that you have to assume epsilon equal to 0 for this to be true, right? Because your model has epsilon. So that means that this A will be on average what Y would be if X is 0 for A. B would be on average Y would increase if X increased by 1. Okay, so everything have to put the average, okay, Y, okay. And the second thing is because of this is a statistical model, and you do notice that there are one parameter we mentioned is called sigma square, because in the regression model there are 3 things. It's alpha, beta, and sigma square. Okay, there are only 3 things that's in model that is have to be common data, right? Because X and Y are driven is observable, right? So only thing you don't know from the regression model is only alpha, beta, and sigma square. Okay, so the thing is we want to guess what is sigma square. Why I want to do that? Because sigma square, remember, represent what? Things we don't know, things we don't observe. There's another thing that is not captured in the model. For example, look at education and income, right? And besides income, there are many things that besides education, there are many things determine your income, right? Maybe your occupation, maybe your GPA, maybe how much time you spend in your homework, how much time you spent in your class, right? How many exercises you actually did by yourself, not copying from your friend or AI or just write some nonsense, right? There's many reasons that affect income, or you get a good job, you get a good interview, so on and so forth, right? So these are the things that actually capture in the sigma square. So that's the first thing to do, is to ask, how can we know sigma square, right? And sigma square is what is the variance error term, okay? So to guess that is very simple, right? You calculate something like the error term and calculate the variance. So that's what we do, okay? To do it, we calculate something called residual, okay? The error is just what the y minus the line, right? If you recall, let's draw this again to make sure that you're okay with that, right? So remember, this is the model, this x and y, okay? And what we said, if underlying model is like this, okay, this is the model we have, right? We imagine this data generated this way, this is our assumption, okay? That means that if this is alpha, maybe use other color. If this is alpha, say, and the slope is a beta, right? So this will be y equal to alpha plus beta x, okay? And if sigma is 0, then you always observe something in the red, right? But we know the sigma is not 0. The other thing that affecting y, right? The income can be affected by the education. So what you get may be there's some point you can observe, right? Okay, and how spread out of this is of course controlled by sigma square. Okay. Okay. And what are the heights, right? This is epsilon, right? And of course, epsilon can be many shapes. Okay. Later we assume to follow the bell curve, but at the moment we didn't assume any bell curve at the moment. But that is epsilon just some error, right? And the error can be small as 0 or can expect as you want. Okay. So what we want to guess this, we want to find out this guy. How can we guess that? Of course, you only collect data, right? The data you collect really depends on what? Depends on what sample you got, right? Maybe you got this number, 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 right? So when you run the regression, you may end up in something like this as well, right? Maybe you end up in this line. Okay, maybe this is your A, and the slope is your B, right? You may A and B can be very different from alpha and beta, but remind yourself this is a blue, it's unbiased estimator, so which means that if you have many of this line, the average of A and average of B will give you alpha and beta. But the particular one we not need to exactly same as alpha and beta. Okay, so this line, right, will be yi hat A plus bx, right? So this is xi, right? Okay, so this is a particular line you get from the least square regression. So from this line, actually, we can guess what is the sigma square. Okay, we can guess this number by doing what? You can guess, you can say the data from the guess line, this is called residual E. Okay, EI. Okay. EI is come from the data, which is this data, right? Is what is xi, yi, right? And this dot here is what is xi, yi hat, right? So the E, the error term will be yi minus yi hat, right? So it's just the same the distance, right? Because the EI, you remember what is epsilon? Epsilon I, it's just yi minus alpha plus beta xi, right? So this is the red line. Okay, it's the same thing, right? We do something similar in the sample, And this EI, okay, if you calculate the standard, so calculate the sample variance, right? The sample variance, right? You just variance. Right, you just sum of and that is why this is the variance, because you can easily check that by construction, sum of this is 0. Okay? The mean of the residual is 0. Okay, so the average of residual also 0. So you calculate everything minus 0 squared is the same thing. Okay? So that's why you can write that. And -2 because we estimate 2 parameter. So that means that -2. Okay. And this is a good guess for sigma squared. So this is good guess for this. Okay. So this is turn out to be, this is the unbiased point estimate of sigma squared. Okay. By looking at the residual, you calculate the sample variance. They give you a good guess of sigma squared. And you ask why we care about sigma squared. 2 reasons. One, sigma squared, right, is telling us how important are all the factors we omit. Right? If sigma squared is small, then our regression is very good. Right? If sigma squared large, I think it's bad. Okay? And second, it will be clear later. Sigma squared, the guess of sigma squared, actually that's we call S. We learned last class, right? This is called S, I think SXY. Okay. I mean, Excel will be STEXY, right? Standard error XY. And this is the crucial for later when we learn hypothesis testing and prediction, confidence level. Everything we need to know this SXY and it will S square XY. Sorry, S square XY. This will be the one that is underlying what we want. Right? So this is the key to calculate so many things. But the first by itself, estimating this, what we call the standard error regression, people sometimes call standard error regression, is the crucial to understand how good is this regression, right? Because if this is large, your regression not so good, right? If it's small, that's nice. Okay, so that is the first thing to judge how good is other factor. Because it's small, regression is super nice. Okay, of course, we learn something more important, more useful than sigma square very soon. But this is the first round, okay, to evaluate how good is your regression. And just to remind you that we have seen this guy. Okay, this guy is the thing you minimize in the regression. Okay, this is exactly what we call the sum of square errors, or sometimes refer is SSE. SSE, sum of square error. Okay, which we'll see soon. But this is something we are minimizing in our regression, right? We're choosing our A and B to minimize this if you look at the least square. And this is called standard error estimate, and sometimes called standard error regression. Okay, so I think we talked about this, and last time we also go to show you this is how we look at the Excel. Right? Excel give you directly STEXY, and you put Y and X, then give you the result. And I also told you how you can do it from scratch, and also look at this. You can see the average value of E actually is 0. Right? The last column, the add up is 0. Okay, so everything is being proven. I actually validate from this example there. So I hope so far okay, because this is nothing but review what we have been doing. Okay, now we are going to the new area, okay, which is something not too complicated at the moment. First, what we want to know is we estimate a model, right? The first thing to do, okay? Remember we learned the two classes. We need to do two things, right? We learned two things. One is estimation. One is called hypothesis testing, right? And we already done the estimation of the model. We estimate that, okay? We told you what's unbiased estimator. The next thing is to do hypothesis testing, okay? The question is the A we found and the B we found different from zero or not, right? Because if A and B, are they meaningful, right? The first thing is to see A is different from zero or not, okay? And at this moment, actually, we cannot do anything, okay, without knowing what the shape is, okay? And there's a method. The first line is telling that actually I show in the slide, but I'm not going to have time to go for the proof. But it can, so the variance A actually coming from this formula, okay? The variance A is actually coming from this formula, okay? Not going to explain how we get it, but I'm going to tell you why this is true, okay? Now the first part is variance A means the intercept, right? If you can imagine that if your sigma square is more, so more random things, your A will be more random, right? You can imagine, look at if you don't see it, think about this. Look at the graph I have. The blue are here, right? Blue are sigma. If you can see the blue are much larger, your A will be fluctuating more, right? Because you have more random stuff, your A will be also more random, okay? And you can see inversely, if you have more data N, you collect more sample, your A will also have less variation. So that's why your sigma square over N, okay, as the first expression. And now let's see the second part, okay, which is a little bit more trickier. Why you have this guy? Okay. So the numerator is say x squared, okay? So sum of x squared means that if x is very large, A will be much larger. You can imagine, very simple. Let me draw a picture, then you see why this is the case. Not difficult to see. Let me run this to consider this two regression, right? So we have this regression, okay, and the same regression here. Okay. If your data is focused on this part instead of this part, okay, you suppose you run the regression, you may end up in here, 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 right? Depends on what data you got, right? So these are all the possible A, okay? But if you draw this one, it can be here, 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 right? So the A much larger, right? Also depends on what data you got. So if you're far away, X is large, then A is larger, right? So that's why it means, that's why you have that. Is that clear? So if your data is far away from zero, your variance is larger, right? Because any small change expand back will be much larger. The second is also not difficult to see, is what? Is the variance of X, right? How the data different from the center. Okay, it's inversely related, right? So this means that if the data are very close to the mean, then you're doomed. Okay, and you have very high variance. Okay, let's see why is the case. Let's draw a picture to justify why we have that. Okay, you can imagine. Again, I have two pictures here. Okay, and I have the okay, and consider data you got is something. Suppose this is the data center is X bar here. Okay. Suppose your data is very close to the mean, right? instead of this case. Okay, so that does that mean if you get a data like this point, then it will be somewhere here. You get some more data, it will be somewhere here, right? But this thing, if you got this data, somewhat, I don't really remember, doesn't care, right? Even though the case, you don't have much variation, right? So if you're way center, then my slight error actually would expand a lot. Okay. So I hope that is the clear. Of course, I just give you some intuitive understanding why it is true. Of course, this have to derive from math. Okay. But now once you have the variance, you already know this very well, this EA is actually alpha, right? So we know the mean and the variance, okay? That's good. But what we need is more, right? We want to do hypothesis testing. So we can't do too much without knowing where A is, right? Because remember when hypothesis testing, right? We have to know the shape and we have to know probability, right? If we remember how we often do it, right? We need to know A is like this, right? If from 0, then you have to show, oh, this is we put 5% all together here. If this is in the green area, then you reject, right? But we have to know this is a bell curve, otherwise we don't, right? So that's why we assume if the other factor we can't see is a bell curve, we can solve, but we don't want to do the math. Actually, the A also follows a bell curve, okay? So this is only when we do hypothesis testing, we need a bell curve, okay? When we do estimation, point estimation, there's no bell curve is needed, okay? Only if we are doing hypothesis testing. And now we know that this A will be follow the mean alpha and variance like this. Okay? And this is called the standard error of A, which is the square root of that part, right? And once we have that, we're pretty much done. Why? Once of this, we just need to know the bell curve, right? We know the variance, right? And we'll use the t distribution, right? Because we never know sigma square, right? We only know the S, right? So we do the t test. Okay. So that's what we do. If we want to know whether alpha equals 0 or not, okay, right? Because we have said, right, this A, right, is like this, is 0, right? We want to check if this area and this area, right, is more, say, 5%, right? 0.025, 0.025, right? And we know what is the variance of A, right? Right, or SD of A, but we don't know it's with the sigma square over n, blah, 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 right? But we don't have this sigma square. We replace by S. So that means that will be T distribution, right? And this T we check is n minus 2. So as long as this thing is not too small and not too big, then we can't reject. Only if it is too big and too small, then we can reject, right? So it's checking the A is too big or too small. Okay. So why we care about that? Because you want to know whether A is 0 or not, right? And second thing to do is to show this point estimate, right? Point estimate, we know that already. That is the best to guess is A, right? And the margin error is T times the standard error. So that means that our CI is like this guy. Okay. So of course you would say, okay, this formula is so complicated, how can we do calculation? And as I told you, right, it's not a calculation class. So I just tell the formula And many of the time, you just rely on the Excel. Okay, I just tell you how you get there. The same as ANOVA. Okay, you are not going to do any calculation except the assignment, optional assignment I give you. But otherwise, I'm not expecting you to do calculation by hand. Right? You're not going, at least not from scratch. So, but want to show you that this example directly do calculation, but later I will show you that how we can do that in Excel very quickly. Okay. So if you see this, we have this thing I have seen in the example so far, right? And the S will be the, remember what this is, this is guessing the sigma. Okay, this guessing how big is the random term, right? And we have shown you that these numbers are there. Okay. So what we want is to test this is 0 or not, right? So just to remind you, what we're doing is looking at A under null is 0. Okay. We're trying to check they belong to this area, this area. Okay. So, and then we'll actually transform, okay? I think the A is 3.9, right? So the data we have is 3.9. So the question is this 3.9 here or 3.9 here? Okay. And we know that this will be transformed to Tn minus 2. Note that it's n minus 2, not n minus 1. So n, we have 5 data, so it's T3. Okay. Is the bell curve? This is 0. So the question is 3.9 is equal to what number here? Okay. 3.9 is what? How can you transform? So 3.9, then you just divide the 3.9 by the standard deviation of A. Okay. And we know the standard deviation of A. It's coming from this equation. Okay. S over root n over sum of the x squared over the sxx. Okay, with this guy. Okay, which is 2.191. So this guy means 3.9 over 2.911 is 1.779. Okay. The question would be 1.799. Is it far away enough? Okay. If you recall what we are doing, this area times 2, is it more than 5% or less than 5%, right? So this is just 1 minus T this 1.99, 1.7793, and you multiply by 2. Okay. And you compare it to 5% or not. Okay. Here I use a critical value method. Okay. And critical value is 3. But also you can see the p-value will be more than 5%, easily check. Okay. So you also would reject that one. Okay. And similarly, you can also do the confidence level, right? Which is 3.9 plus minus the critical value, right? Times the denominator, 2.991. Then you give you the interval, right? So although you get 3.9 there, okay, it can be negative 3.7 or can be as large as 10. So 0 is included, right? So that means that actually you can't exclude 0. So that means that the intercept in this regression, of course, only 5 number, of course, cannot give you a lot, right? But this tells you that, okay, this regression, I will not take very serious about the intercept. For us, intercept will be no different from 0 for us. Okay, so we will not take too much serious about the intercept. Okay. Okay, so probably you ask, okay, what happened if x equals 0? Then probably your best answer is still a 0. Although A you found 3.9, right? On average, it's 3.9, but I will not take too much weight on it. Okay. So after this, then after the break, we're going to go to the most useful one. It's looking at the B. We want to test B, they are 0 or not. This is the most important, right? Because you want to, the main key of this model is to say how X change predict the Y, right? So B is the thing that is a key, right? Because you want to know, right, on average, if you want, say, income and education, right? You want to see additional one more year, is it going to get you more salary, right? So B is very different from 0, is the key, right? Look at regression, you always want to look at the slope. Is it equal to 0 or not? And this is, I guess, if you want to run regression, this is the most important exercise you will do in the beginning. You will try to show that no matter what you do, the B is not different from 0. And then you proceed to other things. When you run regression, this is the first thing you do. Okay? No matter what you're looking at. Okay? B, whether say 0 or not, is the key. Okay? So I guess you guys are very sleepy. So I shouldn't continue through up until 4:15. So let's have a break of 15 minutes and come back. We will deal with the second half of the course, the class. So, oh, there may be low battery. Let's see. If I change the battery first. Okay. So this is, and some of you may have not aware, we don't have a class on next Thursday, right? So we only have exam on the next Thursday. Okay, so this Thursday will be the last time we are in the CYT. Okay, no more CYT after this Thursday. Okay, just to remind you. And some of you said, I mean, we covered a lot of stuff this class, but we didn't saw the proof, so make you feel not the foundation is not very firm. I just reply, all the math is in the slide already. If you really want to go ahead with that, but I guess, I mean, this class is not computation, it's not about math, so I don't want to go into so much detail. So I mean, this level of the material is same as all the business school statistics material. If you go further, it becomes statistics department. Okay, so already that's why the slide you see the gray area box you can forget about. You need it if you really go to stat department, or you need it when you want no further. But this is what you see in the standards that textbook in business school. So that's already this is the one that we already give you is the thing you will see. Okay? So it's not I make it easier or make it more difficult. The same level as you would see in other business school in the world, other parts in the world. So all the leading school, but maybe other leading school may talk up even more about application these days. So even they have lessons. So I guess it's already, although I cut so many already, we are already the very good standard there. Okay, and don't make it more easier, more difficult. Okay? So let's see, continue to see what we have. Yes, you can have unlimited cheat sheet as long as you can bring, okay, any number of papers. You can bring your past paper, you can bring whatever you can bring, okay, there's no limit, as long as physical, okay. As I told you, originally, I actually allow you to bring electronics, but there's a problem of, I can't prevent cheating or Bluetooth or other thing, that's why I can't really allow you to bring, because for me, I don't really care, okay? But if you allow cheating, our AI and this day can be very difficult. I don't know what happens in the future. Probably we have to do all the oral exam rather than written exam because it's very hard to prevent cheating, right? But anyway, yes, very sleepy. I'm also very sleepy. I don't know. I sleep almost throughout the weekend, just sleeping, not doing anything, and take care of some of the children, and then that is what I do. But I still feel very sleepy. The reason I can see is because the temperature changes. It was like hot, now warm, a little bit cold, and then you feel very sleepy. Very normal. Because your body is adjusting. And probably by the end of this week, which become cooler, then I think you'll be fine. But unfortunately, this week is the most important week. So please pay attention. But our class is lucky, we are record. So if you feel you're sleepy, feel free to sleep and then watch it back later. That's okay. It doesn't bother me anyway. So if you really need to sleep, please sleep. So I'm not like a primary school teacher or high school teacher. If you sleep, I feel offended. No, nothing. If you sleep, actually, I feel happy because I help you to sleep, right? It's just good because sleeping actually good for you. Your brain is still growing, your neuron is still going. So please sleep. Actually, I'm helping. So I'm proud of you. I make you sleep. So don't feel bad about that. Answer past paper. We will talk about that on Monday. Okay, just come to class. It will be on Monday. There are quiz. No, I mean, as long as do it, it's fine. Okay, I think I'll check at the maybe by the end of the month. I guess I will check if you finish all the quizzes. Okay, as long as you don't have time, just click and submit, then you're done, right? If you don't even want to do that, I can't help you, right? I don't need to do it. Just click there and submit. showing you are there, and then you're done. But doing the quiz is also help you to prepare your exam as well. So I do recommend you do it. I mean, of course, I don't care about how much grade. I don't care. You do it, you get the grade. Okay. Yes, we'll lesson on Monday, as I said. We'll discuss the past paper. Okay. No class on Thursday because the Thursday night with exam. So I don't want you to come to the CYT and thing. Okay. But of course, you can ask a question for the TA, or in the worst case, you can drop by my office and ask me. But hopefully I'm around, but I should be around, but I'm not 100% sure. But you can just keep emailing me. Okay? How many cheat sheet? Okay. The answer again, I repeat. The answer is infinity. Okay. As much as you can bring. Okay. That's the only thing. Everyone knows Monday. Okay. But I guess you don't want to bring too many, right? Because many pages you can hard time to find which one. Okay, make sure that you bring a lot, but still you're able to find what you want. Otherwise, you can be a troublesome thing to do. Okay. Yeah, I think everyone knows very well the regression, coefficient, the t-stat. Yeah, that's very nice. And overall, it's okay, not too fast, because we're approaching the end, so we are really relaxed. So in case you want me to slow down, I slow down. Okay, we're not in an urgent anymore because we're almost done. Okay, basically we're done with the most stuff already. So you can easily follow, except one person. I hope I don't lose you too much, but you can just watch again. So exactly half of people say we're tired, which, as I said at the beginning, because of temperature. So let's blame them, right? Let's bring the temperature and weather. Okay. Tomorrow's cold. You like winter or summer more? Oh, that's an economist question. When you have too much winter, you want some summer. You have too much summer, you want winter. So I give you the example. Probably some of you know I taught in Singapore for like 7 or 8 years before I come back to CHK. And you have so much summer in Singapore. So the first few years you like it. Okay, just like Hawaii. Oh, nice. And after a while, you have too much sunshine, then you just don't want to have more sunshine. So at the beginning, I don't wear hats, right? As a guy, I mean, usual guy don't care about sunshine, whatever. But sooner or later, they figure, okay, no more sunshine. You have the sun cream on and all the thing, but you have too much sunshine. And I have a friend actually from Scandinavian country, like some Denmark or Norway. Whenever they come and they would just try to get as much sunshine as possible because they don't have much sunshine. Okay, you notice actually when you get, and at the time I go to Denmark in the Christmas time, in December, and in the northern part of the world, almost you only have sunshine for a few hours a day. And then after that, no more sunshine. Whole day is dark. And I joked, he told me once, at that places, people need sun therapy because people are so depressed, they don't have sunshine to have the artificial sun. I was laughing when he told me, but I was there once in December. I feel the same. Okay, I need some sunshine. Why am there? It's so dark, but same. So go back to the question. Which one's more? I think now in Hong Kong, I think it's like in the summer. Actually, I want to be winter. In the winter, I like the summer. And in the fall, like this one, I guess I have too much summer. Actually, I like some cold weather. But I think soon, if you ask me again in January, February, probably I would like summer again. But at the moment, I'll probably prefer to be winter. And the good thing about winter is you can walk without sweating, which is something that I really appreciate when I went to Singapore. But that's a long answer to the question. Am I happy? Yeah, you can see I'm pretty happy. The semester is almost over, and I'm happy, looking forward to see your projects, which I often feel very happy when I read them. And some of you have shown me very interesting project already. I'm looking forward to reading those. Because this is actually the project is also a test for you and also a test for me, because I will see how much I'm going to transfer to you, right? Just trying to see how well I'm teaching, and also it's fun. So in general, I'm very happy. But Yeah, you have to be happy. I mean, even you're sad, you have to be happy, right? Just be positive, right? Actually, thinking about being happy will help. But anyway, I hope you're happy. So now we go to the other one. We want to look at the slope coefficient, how the slope varies. Okay, and as you would imagine, okay, the formula is very similar, right? Just look at this is this is the part you see from the right. If you recall, A will be just this guy. All right. So basically, just take out these two guys. All right, give you this. Sorry, I forgot the square to make sure that I know that is wrong, right? So basically, take out these two guys, you become the variance of B. Okay. The explanation will not be too surprising to you, right? If sigma square is larger, right? The random thing is more, the B will be higher, right? If your slope will be higher if it is far away, the data is far away from the X, right? So much more variation. Not surprising at all. So, and then we'll assume if this is a bell curve, turn out the B is also a bell curve. So it's very not surprising at all, right? Because these A and B are estimated, right? A and B are estimated. Look at A and B are random variable. Okay, it depends on what kind of epsilon you get, right? And you also got the SB, right? Same thing, just take a square root. So you can see the same technique we will be seeing, right? We will do the same. You can test the coefficient. You can do hyper testing. You can also do confidence interval, right? The same before, right? Just draw again, right? You have the B will be 0, will be here. And then the question is asking, okay, how likely that we are in the green area, not in the green area, reject. Okay, we actually want to be a green area because if it's 0, then our model is useless, right? If it's 0, then it's a flat, right? So we want to conclude that actually in the green area. And to do so, we just B over SB because minus 0, and then check Tn minus 2, right? Basically the same, right? Just like you transform this to Tn minus 2, right? Just go to this one, right? 0, right? Just ask ourselves, right? Is it the green area or not? Okay. So that is ID. Right? Just you divide by the standard error, right? Or the variance of the B, right? So that's something we have nowhere where how to do that, right? So as I said, you don't worry too much about actual calculation in regression. That's why we're quick because we'll show you, you'll do Excel directly, give you all the information, okay? You just need to interpret those, okay? Then you are done, okay? You are not actually calculating by hand for regression ANOVA, right? Unless you have nothing to do at night, you can't sleep, then you can do it. Otherwise, no one actually doing that any moment, right? No one actually doing that. And since you are not no one doing that, I'm not asking you to do that, right? You have been doing this for the 1 sample test and 2 sample test. Actually, I ask you to do by hand, but otherwise, I'm not asking you about that. Okay. So that's why you will see I'm a little bit fast here because no one actually doing that anyway. So, and here the same. B is the best estimator for beta, right? And then you can have the critical value, right? This thing and plus minus this will be B, right? So the same thing, same idea we have C. Okay. And let me quickly show you this calculation. And then I will just directly go to the Excel and show you that because you can get all the answer quickly, okay? Here, the same thing, you would do the calculation, calculate the everything, right? You have this guy, or this guy, or this guy, right? Everything's there. You calculate SB, right? Which is S over this guy, right? This we know this over this guy, right? And just divide the B over this, right? It's 1.07, right? So the idea is like this. We have B here. Okay. Should be 0. And your B is what? 0.07. This is come from the regression. So the question is this here or actually it's here, right? It's 0.025, right? is it the orange, is it inside the green or not, right? And you transformed it to Tn minus 2, which is T5. Okay, sorry, T3, because n is 3, n is 5. So that's why 0 here, right? And your 7 is convert to 1.05. Okay, how to do that? This is coming here. Because the standard error, right, standard deviation guessed is 0.6. So if you do the p-value, which I didn't do it explicitly, with just this number, right? So this will be 1 minus t, this, right, 1.05, and then what? 3, true, right? And then multiplied by 2, right? So that would be the p-value, right? And of course, this p-value, even though without calculation, will be big enough, right? Because it's 1, right? This 1 SD is not too far away, right? Or you can do the critical value method. It's 3, so it's not far away enough. So this regression is more or less not very useful. Okay? Of course, the reason why it's not very useful because only have 5 data points, right? If you have more data points, there will be many meaningful. Okay? And you can calculate the confidence interval like this, right? There is no difficulties because this 3.18 is coming from here, and this is coming from the denominator. So of course, I show you many calculation. Of course, you want to say, okay, why go so fast? Because I want to show you that this immediately use Excel add-in, you can get it once and for all. Okay, so that's why I'm very fast here, because all the calculation is very trivial, and I just want you to draw attention to the Excel. Okay, the Excel will calculate everything, because I don't see anyone actually calculate everything by hand, so that's why I just being a little bit fast here. Okay, look at the data again. Let's copy the data I have. It's 4, 7, 6, 4, 9, 1, 2, 3, 4, 5. Okay, so this is a number. So to ease the concern that I skip a lot of calculation, I want to show you that we can calculate this in just one click, and that's done. We see all the number there. Okay. So what we're going to do is, again, we use data analysis tool. So we go to File, Option. Of course, it's a window for the Mac with the same, but you can check how to do Mac. Just analysis tool pack. And data here, data analysis. Okay. And we go to regression. And similarly, just put what's Y. Y just column A. What is column X? It's just B, right? And then because we label there. Okay. And interval 95, whether you click it or not, it doesn't really matter, because you don't do it, 5% is already there. So you don't have to do it unless you want another thing. So 5% is already done. So you just output range, you put just where, and you click here. They're done. Okay, there's not other the thing, you don't really worry about it. At least not this class. You will learn the rest of this crazy stuff if you ever want to do 2021. You spend whole semester to understand the rest of the thing. Okay. Even once you do that, you click OK. It's already in the slide. Don't worry if you why is wrong. Maybe I just can't do that. Sorry. Maybe they don't allow you to do this. See? Yeah, they don't allow me to take the whole column. So if you worry about where to get this thing, you go to the very last end. It's just like slide 77 and onward is what we are covering. Okay. But you will see the thing quickly. Okay. So first, this guy is S. This what we said, the S. Okay, this one we figure out SXY, right? If you're super nervous, this is something we STYX. Okay, so this is the thing that we cover last class already. This is SXY. Okay, this is SXY. This is XY. And this R square we'll cover very soon. Don't worry. Okay, we'll cover R square very soon. And this ANOVA we'll cover very soon. If not, we'll be on Thursday. Okay, this is something we'll cover very soon. Okay, but this is the part we cover just now. So this is A, this is B. Let me write down there, right? Okay. This is just A, right? This is B. Right? And this what? This is SA, this is SB, right? So this is the this is the estimated standard deviation of A and B, right? How good are A and B, right? Because our guessing. And the T will be just this value, right? Which is A over SA, right? This will be B over SB, right? So just column E over column F give you column G, right? And this is something we know we found that, right? And the p-value is something we already showed you how to find that, right? The p-value will be just look at the right-hand side, left-hand side, right? Just look at the T table, right? And the confidence interval will show you how to do that as well, right? Last two columns are the same, right? I same as K, J, and same as L. So you can forget about the duplicated columns, right? So this one, you can forget about this, right? So there's only two, and this is already show you how to do that, right? You can check the slide. So that's why our class is trying to tell you how you can read this, right? So everything is read. At least the last one you know how to read, okay? And the key here, often in your mind is just this guy and this guy and this guy, right? Because these two are F and G's to calculate H and I and J, right? Once you know column E, okay, you know what's the B and A, okay, but that's point estimate. But you want to show that different from zero, so that's why I look at column H, right? And column H show you whether it's less than 5% or not. Okay, if less than 5%, then we're happy. If not than 5%, okay, this is useless regression. But of course, usually the regression should be useful. Okay, and we want this H column to be less than 5%. Okay, and very often you expect this will be okay. Okay, and the I and column J will give you how good are the estimate, right? But once you reject from zero, then you can see how big or small, right? And of course, the more data you collect, this will be more accurate. But this model only 5 data points, so you can't be very good. But in general, this can be very small, especially when you have large data set. This can be very accurate. Okay, and so this is why I don't go too much detail in the calculation. Okay, because everything SASB, I'll give the formula, right? But in fact, you can calculate very quickly. And also, I'm not very serious about this calculation because what you learn from this one is very restrictive. If you learn the other class 2021, they'll give you a way more complicated formula. And that's one you should use. So that's why I just being very loose here. Because, I mean, you will have a better estimate for SA and SB when you go to other class. Okay, you will get a better estimate on those. But I mean, the formula is more complicated, the idea is the same. So that's why I'm little bit too not very serious about going to detail step-by-step calculation because no one actually use it, okay, in practice. But for the moment, I think it's okay. Okay, but even the formula is very complicated, but the logic is the same. They're all the same. The only way is many people spend their life to figure out what is the appropriate SA and SB. Okay, actually, researchers spend time to figure out what's SA, SB, what's the right formula in different situations. Okay, but for the moment, you believe what you give you from the formula. Okay, so you need to know how to do this. In fact, I mean, if you check many years ago, actually, I asked something like this in my exam, same as the ANOVA. But not sure I would do that again, but let's see. But that's what I asked, right? Same as ANOVA, right? I just put question mark on those, ask you how to calculate the same thing. Okay. So not sure I will ask this year or not. I mean, let's see. Okay. Is there any question? So let's continue something very interesting. I think this one very interesting thing is ANOVA. You will ask, oh my God, why is ANOVA again? Right? Why regression do ANOVA? Okay. Turn out to be, if you do analyze ANOVA, analyze variance, that gives you some very interesting, as I said, R square, which we'll cover immediately, R square. So we set the sigma square, right? The variance of the error term is telling us how good the regression is. Okay. But how can you judge, right? If the sigma square is 1,000 or 1 billion, is it good or bad? Okay. You can't really tell, right? So there's actually better measure, which will be called next few slides. It's called R square. The number is from 0 to 1. 1 is the best fit you can imagine. 0 with the worst. So that is the thing that we'll do R square, okay? Which we'll define very soon. But don't worry, it will be something not complicated. Okay. Easier than ANOVA, right? I promise. Very simple. Look at the graph, you know. So SST will be just, let me draw a picture. SST will be just yi minus y bar squared. What does that mean? Look at this graph. Okay. So the green dots are the data point, and the y hat is a regression. Okay. So this is a regression, and this is the data. Okay. And y bar is what? Y bar is the model you would use if your x is rubbish, right? So what is the use of the regression? Your regression that's okay. Is it okay? Yeah. So what do we see is your model, you want to explain this guy, is the thing that different from the mean, right? This thing that, oh, maybe can you help me? Thank you very much. I should have closed the door, but I thought the air would be more fresh if you open. But so this is, you want to explain, right? This is the model to explain, right? You use x, right? If without x, you use the y bar. So this is the thing I want to explain is the distance between the data and the mean. Okay, some of them is called sum of square total, SST. Okay, sum of square total. And what did your model do? Actually, your model actually successfully explained this part. Right? The red part is the part that your model successfully explained. So that is called the sum of square regression. So sum of square, right? This is y hat, this is y bar, right? So y hat minus y bar square is called SSR, right? SST is what? SST is y minus y bar, right? So this is something you explain. This is thing your model explained. Okay, sum of square regression. Okay, your model explained. Okay, SSE. Remember what this is something that we try to minimize, but this is something we can't explain, right? This is a model that we can't explain. SSE. We always want to minimize that part, right? Remember, least square is always want to minimize this part. What's this part? This part is sum of the y minus y hat, right? Because remember, this is the part that we always want to minimize, right? It's the goal. We want to make it to 0, right? Of course, we can't make it to 0, but this is the part we want, right? If this is 0, then perfect fit, right? So that is the idea. We can show two results, which is not surprising to you if you remember last class, which is SST equal to SSR plus SSE. So this is the first thing, okay. Which is not surprising. The blue should be same as the red plus, I don't know, pink, whatever. Right? Of course, this is non-trivial because they're squared, right? So actually, there's some, you usually have to prove it. Okay, of course. Graphically, it looks like this, but it's not proved, right? You have to do the math to prove this is the case. Okay, but once we prove it, we can do the following. We can define R squared as SST SSR. What does that show? So it's the percentage of the variation explained by your model, right? Because SST total won't explain. SSR is what you have explained by your model, and R squared is the percentage explained, right? It must be between, because of the equation, you must between 1 and 0. Okay? So this is the key why we like this, right? Because sigma square, of course, by itself is very good, right? It's good. How good is our regression? Because something was explained, right? But this is more direct, right? Because it's always 0 to 1. When it's 1, the data point all lie on the line. Okay, you can see, right? When the green dot are actually on the line, SSR is equal to SST, right? When R squared is very small, your regression is not as good as you want, okay? And that's why if you ever play a machine learning, or I can check the internet, you can run many types of regression, and that's why they would train your model based on R squared. Okay? You can use different type of combination, right? Because you have a huge data set, right? We got big data, right? Many columns, many X, right? Here only have one X, but you have X1, X2, X3, many X, right? Which kind of X will do the right job? Then you will use the machine learning method. What is the criteria? Look at R squared. What's the best R squared according to pick and choose which kind of regressor you want to use. Okay, but this is only if you learn machine learning classes. Okay, but R squared is the way to look at. Okay, of course, yeah, that's why R squared is good. Okay, R squared being 0 to 1. It's a measurement of that. Okay, so we're happy. Is that okay? So everything written here is already in the slide. So not, if you don't copy, don't worry about it, because I don't create anything new. So everything is there. Okay. R squared, as I said, is called coefficient of determination. Okay. And this guy, right, is here. R squared. R squared. Okay. 27%. Okay. And probably say, okay. What else we see here is also this point. This is SS. Let me write that down. This is SST, right? This is SSR, and this is SSE. Okay. And that's it. Okay. Of course, you will see something called F test. We'll talk about that very soon, so don't worry about that. Okay, we'll talk about F test. But this thing, okay, you see it. Okay. I'll explain this F test now, but so far, is it okay? Okay. No, I give you the F test. So here is example showing you how to do calculation. Okay, how can you calculate SST? Just to do the calculation exactly. Okay, I don't want to bother you with that because you would, I mean, just go to one line, right? So basically, how to get this guy? Remember, y hat should be equal to 3.7 plus, that was A and B. 0.7? I don't know. Or regression is 3.9. A is 3.9, B is 0.7. So the 3.9 is our A, right? Plus 0.7 times X, right? So you just put 1 here, right? 1 plus 1 times 0.7 plus 3.9 is 4.6, right? So on and so forth. Then you get, so how you get this column, right? You put 2 here, you just calculate all this thing, right? And this minus this column gives you this column, right? And I think Y bar is whatever. And then you take the Y bar and you do the same thing, right? I think Y bar is 6. Okay? So that's why everything minus 6, you get this column, right? You take this minus 6, you get this column. And SST will be just what? This square, right? And SSR will be just this square, right? And SSE with this square. And just take the ratio, okay? And in this particular, as a note, in this particular case, this R square is not surprising if R in the topic 1, okay? In single variable, simple linear regression, this R square, in fact, is square of correlation coefficient, okay? In this only particular case, okay? It doesn't hold true for in general. Okay, if you more variables to regress, okay, then you don't have this relation. But turn out that correlation coefficient, it just you take square, become the coefficient of determination, which is very interesting, right? Because you would not expect they're related, but turn out to be they're related in this way. But I mean, I don't want you. If you go to stat department, they keep asking you this. Try to see if you understand or not. But we're not stat department, so it's not a trap for your multiple choice question. Right? I don't think we don't have multiple. I don't think we have multiple choice question. We just make long question. Okay. So, as the last few part, I want you to mention the F test because that's a part that we haven't show you the Excel. So it's talking about the F test. Okay. And the idea is actually the same. Just go back to it. If the regression is rubbish, okay, you should expect SSE and SSR are very similar, right? Because they're actually reflecting the underlying redundant thing. Okay, you use SSE and SSR to estimate the sigma squared, right? They should not be meaningful, right? Because if the regression is great, SSE will be small, right? You imagine, right? If the regression is good, SSE will be small, right? So then you should see a way to compare the variance. Okay, is look at MSR or MSE. Okay, so that is what we want to say, right? Because if your regression is good, right, it says some meaningful, the MSE will be small. MSR much bigger than MS, right? Imagine the perfect case. The SSE error estimate will be very close to 0 when your regression is great. So that's why comparing the variance measured by SSR and SSE, they were done. Okay. Look at this sum of squared, then we have to divide the degree of freedom as we do, right? So why the MSR, you divide by 1 because you only have one variable you use, divide by 1. Okay? You only have one mean. Okay? But if later you see, if you go to 2021, if you have more than you have X, Y, many variable, you divide by that number. Because you only have one grouping. The same as the ANOVA, you only have one group. Right? ANOVA, right? You have your 2 group, then you divide by 2. Your 3 group divide by 3, right? You only have the is divided by 1. And this MSE, right, is says M-2. right? So it's same as S squared. Okay. So it turned out that, okay, it's very interesting. In this particular case, in single variable regression, the F test you do is same as a T test. Okay? The F test is testing whether beta is 0 or not. Okay. And then the way you do is just, we've seen this divided by n minus 2 is F test 1 n minus 2. Okay? Just compare variance. It's variance measured by the SSE and SSR. Right? Then you want SSR contain much more variation, right? Because you will see, right, if the regression is meaningful. And that's the reason why you have here. Okay, let's go back here. Carefully check again. Okay. This is, as I said, this is SSR, and this is what? SSE, and this is SST, and this is what? This is n minus 2. What's n? N is 5. Okay. For our model, always 1, because we only have one regressor. Okay. Okay. And if you be actually more careful, because we have 2 variable and 2 variable minus 1. Okay. Actually, if you look at NOV. But anyway, you can forget about that part. And this plus this equal to that as well. Because this is what? This is it will be n minus 1. Okay. And this guy is what? This guy is this divided this give you this guy. This divide this give you this guy. Okay. This F is actually column F divided by column E, in case you don't see it. Okay. And remember, right? If your regression to be meaningful, your variation should be explained by SSR, right? Rather SSE, right? So SSR must be much bigger than SSE. If that's the case, then you would say your regression will be meaningful, right? So that's how you test the beta is 0, right? So basically your F, right, should be F, that should be 1, then you want it to be somewhere here, right? So that this divided by this give you this number, right? This is MS. For this number, remember this is MSR, this is MSE, right? This is MSE over, sorry, this is MSR over MSE. So it's G will be G12 over G13. Okay. And you can calculate the p-value, right? This p-value comes from what? This p-value is F, this number 1.12214. Degree of freedom is 1 and 3, right? And then true, and 1 minus. Okay, that's the right-hand side. Okay. So this gives you the last value. Okay, you don't need to times 2 because it's one-sided test. Okay, because ANOVA, it's always one side, right? Because must be the regression, the variation explained by regression much higher than the error. That means the beta cannot be 0, right? So that's why you will see, as a last note, which I will release you, this p-value, same as this guy. They're the same. Okay, let's make sure, because they're doing the same thing. Okay, and the next thing is, which is also important, you will imagine, this and this are related. If you take square, give you this guy. Let me prove it. Okay, this guy, square, same thing. So it's, of course, it's not very important, but it's already in the technical slide, but I don't want to make it crazy, but they are related in them. Okay, the P were the same, and the F and the T are related in squared. Okay, in the slide already. But I hope it's okay. But we just only a few slides left, so we will just finish everything on next class and review a little bit about regression, and that's end our whole semester. Okay, I always have fun. I will see you on Thursday.